Welcome back to inverses. Just as a quick summary, what we've seen so far, we were able to find inverse graphs using a couple of little tricks. So inverse graphs, no problem, we did the following. We would take some kind of point that had an x and a y value, and then we'd switch them. So they were the y first and then the x number. And this, of course, is on the inverse graph. So that was a little way to figure out some points on the inverse. And then we also had this method where we reflected across a special line y equals x. And so that was the way we found inverse graphs. What we're going to do today is we're going to try to find the actual inverse functions. So we're going to use an algebraic approach, okay, which is a little bit more exact. It's not just a picture. And I'm just going to give you what the steps are here, and then we'll work through a couple examples and see how it goes. You can see it's sort of not that different than what we did up here. Here we switched the x's and the y's around, and that's exactly what you do algebraically. You switch the x's and the y's. Now, what does that actually mean? Well, it just means that every time you see a y, you write an x. And every time you see an x, then you write a y. So that's the first thing you do. And then the second thing you do is you solve for y. And the reason for that is that your function is going to look pretty funny if it says x equals da-da-da-da-da. And that's just not the way you ever write functions. So we're supposed to then solve for y. So let's do an example or two and have a little look. Okay, so first little example, let's say we had the following function. F of x equals 4x minus 1. Okay, so our job is to find f inverse. Okay, so away we go. By the way, f of x is the same thing as y, right? So when we switch x's and y's, the first y here becomes an x. And then we have 4x. Well, I'm going to write that as 4y minus 1. So we've switched it all up. It's all good. All I've got to do now is isolate the y. I want to solve for y. So I'm going to add the 1 over. And then I'm going to divide by 4. And it looks a little funny because it has function equals y. So that's a little strange. I'm going to spin the whole thing around like this. And it still looks a little funny. Actually not really too bad, but it's better if you're trying to find f inverse, then you might as well say, hey, by the way, this isn't just any old y equals, this is f inverse. This is the inverse function of this original function f. Okay, so there it is. That's all there is to it. Pretty easy. Well, I shouldn't say that, because the next example shows you sometimes it can get a little tricky. So I'm going to clear the screen, look at the next example. What if your function, let's make this guy g of x, looks like this. So it's not just a nice little line. There's a little trick with ones like this. So we're going to try to find g inverse of x. That's our goal. Okay, so again, this is the same as y. So I'm going to switch my x's and my y's around. Okay. Then I can see, I got fractions. So what I'm going to do is I'm going to multiply by the denominator here, y minus 4, and I got to do that to both sides. That's just to get rid of the fraction. So this can cancel. So I have 2y equals, and this is going to be x times y, and then x times negative 4, so minus 4x. Now here's where mostly students get to, and then sometimes they just don't know what to do anymore. So this is the trick. So watch closely. You get all the terms that have a y in it on the same side. So I'm going to subtract over that 2y. I'm going to take the terms that don't have a y in it, like negative 4x. I'm going to add it to the other side. Okay, so all the terms on the left side have y's, and this guy over here doesn't. Then here's the secret. You factor out the y. Okay. Once that is factored, then you can divide by what you have in the brackets. So here's what I end up with. 4x divided by x minus 2. So there it is. There's G inverse. Somebody wanted to know. So there's G inverse. It's 4x divided by x minus 2. All right, I think we have time for one more example. What if things got a little messy and you had, say, a quadratic function? Let's say you had some sort of function. Let's call this guy h of x. Let's say you had some function like x minus 2 squared minus 3. Okay, and again, we're trying to find the inverse. Okay, so inverse is what? Well, again, this is a y. So all the y's become x's, and all the x's become y's. So I go, okay, I did the switch. Very good. Now I'm going to solve for y. So in this case, I'm going to add 3 over to the other side. Okay, so that's good. I'm going to take this here, and I'm going to try to solve for y. So it means I'm going to have to square root to get rid of the squaring. Now remember, when you do that, this will actually become plus or minus. Okay, and then over here you have y minus 2. The squaring is gone. And then we're going to add the 2 over. So here it is. There we have it. Okay, and that equals y. Or perhaps we'll write it in a neater form, h inverse of x. And it looks like this. 2 plus or minus square root of x plus 3. Now I'm just going to mention this is not an inverse function. All I can say about it, it is an inverse relation. And the reason I know it's not a function is because it fails our vertical line test, or just an analysis that, let's say we plugged in some number like 1. Let me show you what I'm getting at. If I plugged in 1, I'd have a 1 here, so that would be 1 plus 3 that I'm square rooting. Actually, I'll do the math over here. 2 plus or minus square root of 1 plus 3, so that's 4. So I would have 2 plus or minus the square root of 4, which is 2. Hey, wait a minute. I'm getting two numbers here. I'm getting either 4 or 0. Well, true functions, you're not allowed to have two y values. You can't go to your grid and say, okay, there's 2 points here. When x is 1, you're up at 1, 2, 3, 4. You're up here, or you could be down here. See, this fails a vertical line test. So that's why it's only a relation, not a function. Okay? It has to pass the vertical line test to be a function, and this does not. Typically, if you see plus or minus, you'll know that's not a function. Okay, that's probably a good place to stop for now.